Hi, everyone. Today we are going to be talking about chapters 12 and 13, all about experimental design. So experimental design is a quantitative method that is appropriate for research purposes that are trying to understand if there is a causal relationship between variables. So this type of research is hypothesizing and asking, does the independent variable cause the dependent variable? And so if that is your research purpose, you need to use an experimental design. So it's considered the strongest method for investigating causation. However, within experimental design, some of them are weak and some of them are strong. And so these chapters talk about the components of those. And the key point about that is stronger designs have random assignment, meaning that the participants are randomly assigned to either the control group or the experimental design. Now, these causal relationships are established in experimental research when the researcher can manipulate the independent variable and measure whether or not that independent variable is causing a change in the dependent variable. So this may or may not be appropriate for your research proposal. However, it's important that you understand the overall components of experimental research so you can be more critical consumers of it and evaluate the strengths and the quality of the research design so you can interpret the claims accordingly. So when we are reading chapter 12, it starts off by talking about some different experimental research settings, and starting about how you might evaluate the quality of claims is thinking about the pros and cons of each setting and what limitations they offer. So the first is field experiments that are conducted in the natural world in real life settings. And these have the benefit of having higher external validity, meaning that it's more generalizable to other settings. And that makes sense because the research is conducted in real life settings in a school, in a university, in an athletic facility. However, it can be harder to control for confounding variables. Now, laboratory experiments, it's much easier to control for confounding variables. However, it might not be as generalizable due to the research taking place in a lab setting. And then internet research has been expanding, and internet research has the benefit of being able to reach participants across time and space in many ways, and having some of the features of a field experience because our internet and our online lives are becoming more and more entangled with real life settings. However, it does have some limitations in terms of being able to control for the confounding variables. So thinking about those, and particularly in education, what settings might be most useful for which questions and what limitations might arise. Now, this idea of manipulating the independent variable is paramount to experimental research. So all experimental research involves manipulating the independent variable. And that's not always possible. So we'll talk about some designs where you are not able to manipulate the independent variable but for these purposes, we are going to talk about situations where you can manipulate the independent variable. So thinking about independent variables that you can manipulate, these are things like an intervention, a treatment, a particular protocol that participants can try. And so you can have one group of participants do the treatment and the other does not. So that's what we mean by manipulation. So there's 3 different types of independent variable manipulation discussed in this chapter: either the presence or the absence of the treatment, like in a control group, the amount, variations in the intensity or method, and then the type. So you'll see some figures in the text. There's a lot of figures and examples in both of these chapters. I'm just including a few, but be sure that you look at those as well. So in experimental research, all experimental research, the independent variable is manipulated. So really important in experimental research is being able to control for those founding variables. Like we talked about, you want to be able to isolate the effect of the independent variable on the dependent variable. And this is important for internal validity, that causal validity, which is the purpose of experimental research. So the goal when you are controlling for confounding variables is to equate the groups to eliminate any differential influence that a confounding variable is having on that dependent variable. So here are 6 methods that researchers can use in experimental design to control for confounding variables. Now, the gold standard method is random assignment, and that is that is when the researchers randomly assign participants to either the control group or the experimental group. And that is theoretically, from a statistical point of view, a method to ensure that the groups are equivalent at the start by randomly assigning them. So you're not letting participants choose which group they're in, and you're able to randomly assign them. Matching is when you match the participants based on similar characteristics. That way, both groups are about equal. You can also hold the extraneous variable constant, maybe gender or socioeconomic status, or you can build it into the research design. There's also methods for statistical control where researchers are able to statistically control for any differences in the means of the groups before they start analyzing whether or not the independent variable is causing the dependent variable. And then counterbalancing, when you're using repeated measures, you can control there in order as well to make sure that you're not having a differential influence. So just a note on random sampling versus random assignment. I've just found this image, if it's helpful. The text has one too. But we talked about earlier that in research design, there's many different types of methods. There's sampling methods, there's methods to ensure validity, there's data collection methods. So random sampling is a method to select your participants from the population. Random assignment is a method that you can use to assign your participants to the groups. So I wish that, so they are different. However, you can use both together. So if you move this underneath, you could have random sampling. In the text, their visual has it like this too. You have the population. From there, you draw your random sample. And from your random sample, you randomly assign those participants to either the control group or the treatment group. And random assignment is a method to control for confounding variables. So this is in the text, the continuum of weak to strong experimental designs. And so we're going to talk about some of the components of each and what makes some designs weak and what makes some strong. So starting off with weak design, they do manipulate the independent variable. However, they lack control over the confounding variables. And one example would be one group, post-test only design. So there is no group to compare it to, and you also don't have a pretest to compare it to. You could also have one group pretest, post-test. So now you can compare their pretest to the post-test. However, there's not a comparison group, so it's hard to have evidence of a causal relationship. You can also have two groups, but non-equivalent and post-test only. So even though there's two groups and you just have that post-test without random assignment, it can be hard to have evidence of causation. So those are some examples of weak experimental design. Now, compared to strong experimental design, these have maximum control over the confounding variables. In the text, it mentions that sometimes this research is called random controlled trials. You hear the random and then the controlled. You might hear that in medical research or just when you are reading or on the news. So you may have been familiar with that. So one common design is pretest, post-test, control group design. So you have participants randomly assigned to either the control group or the experimental group, and both groups are taking a pretest and a post-test to see if the independent variable is causing the dependent variable. You can also have post-test only with a control group that's randomly assigned without a pretest. And then these are two advanced methods that are detailed in the text, a factorial design, if you are considering multiple independent variables simultaneously, and then repeated measures where the participants are being exposed to all different treatment conditions. Again, if you have multiple variables. So I have an example of a piece of research that uses experimental design for you to think about just from the abstract. I have this here. So as I am going over the abstract with you, I want you to think about what keywords in the abstract signify that it is strong experimental design, and then what questions would you ask in assessing the validity of this study? So of course, some of these are discussed in the methods of the article, but just as for practice, as you're thinking about evaluating research, what questions would you be asking or wondering when you're assessing the quality? So this is an article from Education Evaluation and Policy Analysis, and it is about the effects of summer mathematics intervention for low-income children, a randomized experiment. So notice the phrasing here, the effect of, so you can tell they're looking at the relationship. You can see their variables. The summer mathematics intervention is their independent variable, and the dependent variable is assumed here, the math achievement of those students. So here in the abstract, it might be kind of small, so I will just kind of run over this for you. So they're saying that prior research suggests that summer learning loss among low-income children contributes to income-based gaps in achievement and educational attainment. We present results from a randomized experiment of a summer mathematics program conducted in a large, high-poverty urban public school district. Children in the 3rd to 9th grade, then this means how many participants they have. N equals 263, were randomly assigned to an offer of an online summer mathematics program, the same program plus a free laptop computer, or the control group. Being randomly assigned to the program plus laptop condition caused children to experience significantly higher reported levels of summer home mathematics engagement relative to their peers in the control group. Treatment and control children perform similarly on distal measures of academic achievement. We discuss implications for future research. So what keywords, and feel free to pause, and I'm going to put a link to this in the perusal if you need to make it bigger to see, or if you're interested in this research. But what keywords did you hear that signify strong experimental design? And as a critical consumer, what questions are you asking in terms of their validity? Oh, oh, I should have done that. Oh, well, moving on. Okay, so chapter 3 talks about quasi-experimental research. So this is stronger than weak design, but not as strong as strong. So it is better, but it often lacks random assignment. And this is used when it's not possible to randomly assign participants to a group, which is common in education. One of the examples in the text is about, for instance, if students are already in 2 different classes, you're not going to change students' classes mid-year just so you can have them randomly assigned to either the treatment group or the control group. So you might pick one classroom gets the treatment and the other serves as the control group, but you're not able to randomly assign them. So that is a key difference with quasi-experimental research. So you're manipulating the independent variable, but lacking some random assignment. So when we come back to, and this was discussed in an earlier chapter, when your research purpose in quantitative design is causation, it's important that the relationship between the variables meet these 3 criteria in order to have evidence of causation. So the cause must co-vary with the effect. So there needs to be a relationship between them. So that is able to be established in quasi-experimental design. The cause must precede the effect. That's also possible in quasi-experimental design because it's manipulated. However, this last criteria is the most difficult and the one that has the most issues in establishing a causal relationship. And that is eliminating any rival hypotheses or alternative explanations. And so the text talks about some methods that researchers can do and you can do when you're evaluating research to make sure that you are considering rival hypotheses. Okay, so let's talk about some of those quasi-experimental designs. So one of them is non-equivalent comparison group design. So the groups are non-equivalent because you're not having random assignment. So this is similar to experimental design. However, so you still have your control group, you still have your experimental group, and you still have manipulation of the independent variable. However, they weren't randomly assigned. So a way to control is to use that statistical control, and this compares the means and the characteristics of members of the group, of each groups, to control for any differences, to isolate those out, to make sure that you are just looking at the independent variable and the dependent variable. So for instance, maybe a school is implementing a new science curriculum and they're doing it mid-year, so they're not going to randomly assign students to who gets it and who doesn't. So they give it to one grade level and not the other. But they're going to need to use statistical control. Perhaps one grade level had higher science aptitudes before than the other. So by using statistical control, then they're able to compare. So some potential threats to internal validity, this is table 13 points. I'll come back to it. But these are some of the threats and the potential biases that can impact it. So when you're evaluating the quality of quasi-experimental design, you can think about some of these. So selection, since there's not random assignment, how could that be impacting it? Maturation, perhaps one group, if you do maybe third grade and fourth grade, maybe fourth graders mature at a higher pace than third graders. I don't know. So there are these different, like history, maybe something happens there. So these are some of the potential threats that are particularly relevant in a non-equivalent comparison group design. Now you can also have an interrupted time series design. So this is when you are using one group, and since you don't have a comparison group, you do multiple pre-tests to establish a baseline and then multiple post-tests to help improve the validity. So here is a sketch of what it might look like. So as you can see, the baseline was multiple data points, and then in the post-test and during the intervention, there were multiple data points as well. So, but one weakness with, okay, so we also have this method here, this design regression discontinuity design. And this is when participants are assigned to the control group based on a cutoff score. And after the intervention, they retest the line. And if there is a break in the line, this discontinuity, they're able to establish that the treatment had an impact. So if it didn't, and there's a photo or a sketch of this in the text too, this line just stays the same. So an example might be gifted program. And so students are admitted to the program based on a particular cutoff score. And then after maybe 6 months, they're tested again to see, did the gifted program positively impact their score? So you would expect to see this break. And this is considered one of the strongest with quasi-experimental. So here are some of the considerations to make sure that that design is actually strong. Okay, so we also have some single case experimental designs that can be used for an individual or even a small group. So when we were discussing the interrupted time series here, this could be like this example was percentage of students off task. And so you can see here they had the baseline data, and then during the intervention, this is what it was. Now, similar to this, but you have the single case experimental design. So this is when you are studying an individual or a small group, And we have both ABA and ABAB designs. So you get a baseline in the similar way that we talked about, the interrupted treatment. Then during the treatment, you have multiple data points, and then you remove the treatment and you have some at baseline again, to see if the treatment is causing that effect. So based on this graph, there is evidence that the treatment is causing this decrease. But a limitation of this is carryover effect, because often in education, we hope that whatever intervention we are implementing will have a long-term impact, even when it's removed. So in that case, you can use some other designs like a multiple baseline and changing criterion designs. So multiple baseline is similar to the single case experimental design in that you have multiple baselines. However, the treatment is introduced at different times, and so you're able to continue it, and you don't have to expect the reverting. So here you can see baseline, and then as the treatment increases, and then here is another participant as well. So you can see that relationship there. And then change in criterion design when the treatment is gradually adjusted over time. So when researchers are considering a quasi-experimental design, since it is, you want to make it, it's not going to be as strong experimental design because it lacks random assignment, very good. But there are some things that researchers can plan to make their quasi-experimental design as strong as possible. So one things to think about, depending on which of these designs is being employed, if you're using a single case, having that stable baseline to make sure that there's as little variability as possible to assess change. That's really important. If you are testing more than one variable, introduce one variable at a time so you can isolate it. Think about how you might alter the phase length and then the treatment effect to look at how the data are changing. And here is an example of quasi-experimental design. I will expand it so you can see, but similarly to before, what keywords in the abstract signify to you that it's quasi-experimental, and what questions would you ask in terms of its validity. So this study was published in the journal Behavior Modification, and it is on the effect of visual performance feedback on teacher use of specific behavior praise. So they were looking at the effects of what they call the visual performance feedback on teacher use of behavior-specific praise. So they were evaluating, trying to coach teachers into using these specific behavior praises, and they were giving them this visual performance feedback while they were doing it. In addition to receiving individual VPF, teachers participated in group consultation focused on increasing competence in the use of behavior-specific praise. 3 general education elementary teachers and 6 students participated in the study. Classroom peer composite data were also collected. Teacher and student behaviors were monitored across baseline and VPF conditions in a multiple baselines design. The results indicated that VPF resulted in an increase in behavior-specific praise for participating students across all teachers relative to baseline. Additionally, teachers increased their use of behavior-specific praise with classroom peers. The findings highlight the need for direct assessment of intervention implementation and for the collection of peer data to identify collateral intervention effects. So what did you hear in this abstract that signifies quasi-experimental design, and what questions do you have for the validity? So I look forward to your comments and questions about these chapters and other examples and connections that you may have.